right? Most people got like what it stands for, right? Object relational mapping. The next thing is just like really translate like what that means, you know? So it's like the relations are the tables, and it's mapping this uh, to the object. The people that really gave strong answers was okay, we're mapping really like a class to a table and a row to an instance or an instance of a class to a row in the database. So ones that I liked, models that create object instances out of data table records. Yeah, you can just say out of table records or records in the table, and define relations between those objects. Yeah, that's pretty good. Um, we instantiate classes and map them to records. So this is good, right? Because it's like an instance, right, is each individual object, and that maps to a row in the database. We continue to develop mainly in, okay, I like this statement a lot, like the second line. So it says we continue to develop mainly in the OOP, the object-oriented programming language of choice, and do not have to worry as much about developing large SQL statements in code. Like that's quite good, right? Like it's like we might enjoy writing in Python more. We can also kind of break these SQL statements into functions. Like it shows kind of like understanding how this helps us. And notice, like, this is not very intellectual. You just think through, like, what pain, how does it cause less pain by using this ORM, right? And that's really what like, one thing I want to emphasize is, like, in data engineering and engineering in general, like, things are changing all the time. So there's not going to be, like, a book that's, I mean, I'm sure people have plenty of opinions and there'll be lots of blog posts, but those opinions should be based, like, in part based on experience, right? And like when you're like start talking based on like your experience and like thinking critically about your experience working with these different tools, that really shows. And that's like kind of like an engineer, right? So anyway, I like this answer because because I think it reflects that. An ORM is an object or class that corresponds directly to a table consisting, I like this part, consisting of properties that relate to the actual fields, right? So it's like the instance properties relate to the columns in the table and methods for getting and setting the data in those fields, right? So that's just something I didn't emphasize, but I like the fact that, you guys drew that out. I didn't look at who wrote these, by the way. So if I choose yours one way or the other, it's just by chance. Okay, so what problem does the ORM solve? Okay, so this is really more. I just want to clear up like some of the confusion I saw too. It's not. So this one says it helps normalize different data sources by first converting everything into objects, which streamlines the data ingestion process. Right. This is more. To me, that describes more like the adapter pattern. Right. The ORM is just data in the table that's pretty well formatted to data in a class that then maps to that. So once it gets to the table, at least with the patterns we've seen so far, it should be pretty well formatted. So it doesn't really streamline data ingestion, I don't think. I mean, I can see how it's part of it, but that's not the main point. This one, okay. Supplies method. No, I like this. I don't think this is bad. Modern databases are really fast and efficient, but can be cumbersome to interact with. And ORM supplies methods needed to make the interaction between the database. I mean, yeah, it's okay. A database and the rest of the code base relatively painless. I think the main thing is I would talk about, okay, it brings our data into Python where it can interact with the rest of the code base, right? Maybe that's the idea that this person was getting at. This is interesting. I thought this was interesting because I don't remember talking about this, but it is true. It's a common kind of. So the answer here, the response was, an ORM makes our code flexible and not tied down to any one database or backend. If any changes happen in terms of the backend DB, we can still use the ORM layer with minimal SQL changes. So let me just illustrate this concept a bit more. This so right, we have our class. I wish I could draw better. And that this relates right to a database underneath, right? And we have a class called like, person, right? And then we have a table, a person's table with like different records, different rows of data. So the point is like, here, maybe you have, if you think about like the instance, right? And then you have the self.id and things like that, right? So this logic, if we have something, let's say even called def person, let's say has many like orders, and now I do like select all from orders. Let's say one day, if we ever change, so we do select all from orders, and then I want to do one more thing. Now I have a controller, right? And I have this app equals like Flask app, and I do app.get, and let's say you get a person, and then from here we do, here's my person, takes the ID, and now I not only will I return the person, right? Find let's say person of that ID, and then I also return the orders. Let's say say this is Postgres, select all from orders, but eventually like we change to like BigQuery or even like MongoDB or something, and this statement just no longer applies. All right, like we need to change the SQL because we remove this database and we pop in a different one because we need to. Somebody makes a decision somewhere and we need to. Well, what's interesting is none of this probably has to change. It's like find the person, get the orders. The part that will have to change is underneath, how we actually get the orders. So this is the benefit of like this function kind of abstracts away, right, the SQL. And so we're going from SQL to Python, and because the rest of our code just relies on Python, then once we can change this whole database, but any of our Python code doesn't really need to get affected because once we hit this ORM layer, we've we've abstracted away the SQL call. All right, so that's the point I think the person was making, which is like, if you isolate, it's kind of like if you isolate all your SQL calls in this model layer, and then you just rely on that model layer throughout the rest of your app, then if the SQL changes, if this database ever changes, that change isn't going to get trickled through to the rest of your application. It just stays here, right? In contrast to if we found the person by literally writing out a select statement over here. Now our SQL calls are kind of scattered all over our code base. In this case, they're in the model layer. It's an interesting idea, right? Let me share this. Okay. See, this was this last one makes writing code easier. It's in the choice of your language. Simple, but I think to the point. I like it. Like, it doesn't seem very sophisticated, but I think it's right. Like, what is the point of an ORM? Like, we get to now write in Python. It's like I can expand upon that, right? Like if this was an interview. Well, now instead of writing, these SQL calls that could be trickier, we just write the SQL calls once, and then we like inside a function, and then we just call that function. This one started off good, and it got some of the answers then were a little not quite right. But okay, I like this a lot. Don't write the same SQL queries over again and again. That's totally true, because if I have a function called like orders, right, then I know that's in my person class. Then I just call person.orders, and now it's organized. I also know like exactly where this query is. It's in the person class, right? It makes sense that it is, and I can always just call that function instead of have to rewrite this. I can use a programming language like Python to interact with the data. Also very good. Like we can perform the select, and then we have this other tool of Python. Great. I can extract and manipulate data from different types of sources in the same model. See, this is really the adapter pattern, right? This is really like once we have this data in these different, coming from these different APIs, then we load it into the database, right? But even if you load it into the database, and if you take all these different sources, load it into the same table, like the persons table or the venues table, and like you remove Python from it, it's still kind of it's still consolidated in that same table, even without this ORM level of Python. All right, so this one I don't totally agree with. I can perform complex operations on the data. I don't maybe. It allows me, I would want the person to expand more on that. It allows me to easily interact with databases to create apps or APIs. Yeah, I guess so. Yeah, I just say like I really like these first few ones. Like this first one's really good. This one's really good, right? It shows kind of like the pain, and it's very specific to an ORM. Right, this one, now it feels like we're starting to talk maybe a little bit more about the adapter pattern. What's a model? Okay, model is the intermediary between fetching data from the database to the view. It implements logic that is relevant to the data. So just to, like, I'd say that's really MVC relevant, but a model is it's tied to the table. You know what I mean? Like, I get what the person's saying. Like, we use the model we've used it in this MVC pattern. But when someone talks about a model, I think what you should be thinking about is models are very closely related to our database. Okay? That's really what you want to emphasize. Because that other thing, like I would think of like the controller as something that like fetches data, and then sends it back to the view. Controllers are very related to the view. Okay? It's very related to like the web specifically, taking a request from a web page and then sending back JSON or HTML, right? That's a controller. Controllers are very related to the view, okay? Our model is kind of over here, like whether or not like it's used for sending data back or not, we still might want a model just to interact with our database more easily, okay? So I would just emphasize models, databases, models, table, right? It kind of like falls in line with our ORM idea. A model is a class that corresponds to a table in the database. That's exactly right. Having properties that correspond to the table columns, getter setter methods for retrieving values in this property. This sounds very good to me. Model is close to the database. Excellent. It is between the controller and the data. That's basically, I agree with that. Plays a role of managing data for a particular class. Yeah, this is right. Plays a role for managing data of a particular class. So right here, the emphasis is like we are right. It just says it right up front. We're close to the database. It explains that, hey, I understand MVC because the reason why I guess you're close to the controller is because if here's the controller and we do persons.get, here's my controller action. Here, all of a sudden, once we use this class and then call it, now we're having the controller call the model, which calls the database, right? So I guess this model is further down on the stack than the controller. Okay, a model is used to manage the data and logic of the application. Okay, the reason why I wanted to, the reason why I want to bring these up, right, I want to just clear up some confusion. I mean, data, yeah. Logic of the application, not really. Yes, it is, but so are other objects, right? So is your whole code base, basically, So, for instance, like our adapter object, when we get to that in a little bit, like that also plays a role like transforming stuff. There are other objects. There are other kinds of objects. There's something called like service objects. So there are other that also do a lot of logic. We haven't learned about it, but yeah, I'd say really anytime we use object orientation, right? Objects are, if you think about what an object is, it is like functions. And this, by functions, you would also think of that as like behavior. right? And I almost wrote the word logic because it falls into it, and data, right? We store, when we do like self.id, self.name, self.anything, right? We're storing data there. So like, I would say like this almost applies more to objects in general than models, right? Models are a kind of object that are closely tied to the database. All right. So before we move on, ORMs, ORM, again, like object relation mapping, the key thing is just like table maps to class, instance maps to like a record in the database. Problem does ORM solve. It makes it, I think these answers did a good job of covering them, right? Like one key thing is like we get to wrap our methods, our SQL statements in methods, and we get to like easily convert our records in a database to Python objects. The model, right? Just want to make sure you have that a model is closely related to a table. The controller here. Now we get to the controller. Yeah, I love the view. Yeah, just the controller is related to the view. Controller performs the actions. I really like that phrase as well. That enable the user to access the view. I'd say that sends back a response to the user or something like that. I would just change the wording here, but the idea is spot on. Specifically, the view is the data. There you go. The view is the data / results displayed in the browser, while the controller is the code that maps the routes and functions that direct data to the browser window. So like, yeah, maybe like some of the words I would change, but conceptually, I think this is right on. The controller is responsible for ingesting user input, processing that input. So here you just mean, instead of user input, I would say like requests, like use the word like requests from the user, right? By request, we mean like that request library, or when you go to like /users or espn.com/NHL, right? Delivering the appropriate output. And then here I would put the word response, right? You just get more credit for saying these words. The view serves to display the output in a specific format. Yeah, but overall this is good. Between the model and the view, really nice. It's what executes the request that the user sends. Excellent. The controller has a route of /product. I really like this too. It's like first you're talking like conceptually, and then you show me like concretely, that you understand what's going on. If sometimes in interviews it's hard to like put this stuff into words conceptually, so you may say, hey, yeah, let me give you an example of what the controller does, and then from that concrete example, then you can abstract and say, okay, so you can see that the controller is, this might be the second statement you say, but either way, this is great. The controller has a route of /products. If the user sends a request, the controller would have a method called products.all. Go to the model, yeah, and get the information. The user get this information, send it back to the user in the form of JSON. That's great. Yeah, so one point I wanted to say, a number of you said like Flask, mentioned Flask, which is not bad, but I just wanted you to make sure you get that this pattern applies across different languages, across different libraries. Like you can do this in JavaScript. They have this idea. You can do it right with Node. You can do this in definitely Ruby on Rails. It's like built into it. Flask, sure. Django, right, is another Python library. So I wouldn't word this as like this is a pattern in Flask. No, this is an object-oriented design pattern common with websites that allows this type of stuff. And now this is the adapter pattern. Takes messy data from multiple sources, APIs, cleans and packages them into the database. And pretty beautiful. The adapter pattern lets us neatly wrap the code we use to coerce our data from our client into what we want for the target. Yeah. Okay, I really like the second part because this shows like a really nice understanding. Without an adapter object, we might have to write loops and other code every time we want to make a target instance from the code we pull from the client. Yeah, it may seem a little wordy, I guess, but what's nice about it is whoever wrote this kind of like understands that, we have this data. Let me clear this. So remember like the adapter pattern, right? We get back, we start with like this JSON. We do this request.get somewhere. And we get back like this messy JSON of like, here's the venues and like, we have these venue objects. And then like each venue object has like these IDs, and then maybe there's categories. And then it's all nested, right? This is just like representing one venue. And it's kind of messy, right? And there's extra stuff we don't want. So the whole idea of the adapter thing is, this is going to be, I guess, our client. And then we have the class of adapter, right? And the whole idea is we were going to take this response, and instead of me, every time I want to know, like, what are the categories associated with its venue, that I have to, like, go through this nested JSON, instead what we'll do is we'll simply clean it up the first time, right? Right when I make a request, clean it up, load it into the database with this adapter pattern, right? We'll do something like venue builder or whatever. That's where these venue builders come in. And this, we have that def run. And ultimately, right, we select attributes, and then we actually build a venue, right? And once we do this and we load it into our database, now our data is like cleaned in the way we want it. And so we don't have to worry about this messy data ever again. If we didn't have this, then every time I want to access the data of like what are the categories associated with this venues, I'm going to have to worry about, I'm going to have to work through this mess every time. The point is here, yeah, this is a mess, so just handle it right away, and then we can work with the data the way that we want it. All right? Okay? It's just like cleaning your room. You just want things in place, and then you have to search around every time you want to find something. So whoever, that's why I really like that answer, because it really shows like an understanding of the pain of, okay, without the adapter pattern, what would happen if we didn't have this thing, right? That's a really great way of answering questions of like, without it, here's what we would have to do. If you can start a sentence with this, and you can finish it too, that you're in a very good spot, I would say. Like that's a hard thing to do. I would have to think through each of these. It would take a second for me to think through that. What are each of the models? Okay, this was a bad question because it shouldn't be called what are each of the models. I should have said what are each of the objects in the adapter pattern. Yeah, and this is generally right. The extract model downloads. I guess it was okay that this person mapped this to ETL, but this is really the client object loads data from the external API. This is the transform is what is the adapter. But it's okay. Honestly, the more I think about it, it's okay that I wouldn't matter that I would not care that much if I was interviewing someone and they said that. Manipulates the data into the right format, and then the load. What I would want you to get is like this is just actually the model, right? Like the venue model, right? And the model saves the data into the database. All right. So client hits the API, the adapter changes that data into the right format, then the model saves the data into the database. That's it. So like takeaways in general, I'd say, yeah, this idea of like, okay, without this, what is the pain that this solves? Okay. Thinking, I guess, I like the same thing, right? Just interaction. Yeah, the model is closely tied to the table. Yeah, so you're just thinking about the pain. That's very useful. So this answer was another example. Don't write the same SQL queries again and again. Right, like organizes our SQL queries with an ORM. Right. So just really thinking like, oh, and then that other technique somebody used about providing an example. Right. They did that, I think, with the MVC. Here we go. Example, the controller has a route of products, right? So if you're having trouble providing an answer, then like, yeah, let me give you an example of that, right? Give the person an example, and then you can abstract away from it, right? Okay, so think of the pain point, right? How would our life be different if we don't have this thing? And then two, think of something concretely, I guess, right? That sometimes like that can be useful. And then you want to kind of draw the larger point. It is between a model and view. It executes the request. That's great. That's what a controller does. All right. Questions about the quiz or like answering these kinds of questions? It is good practice. Like I know a lot of you all are keeping up with Obsidian and your outline. It's good practice to try to write this stuff out. Like both, like you'll get answers like you'll come across these questions specifically and you'll be a little bit more prepared, but then two, you'll just practice explaining like technical concepts, which is hard to do. All right, I'll try to keep giving these types of quizzes and things like that. All right, cool. All right, so then the next thing we want to talk about is window functions. So for that, yeah, Micah can take it away.
Yeah, sure. Give me 1 second while I share my screen. All right, cool. So yeah, today we're gonna go over window functions and basically how they differentiate between group by and how to use aggregations and the benefits of SQL window functions to solve different problems. So let's just start off by loading our data into pandas. I have this already here, so go ahead and run that. Okay, let's just make sure that works. Check our data frame, get the last three. Cool. Awesome. And now let's just import it into a SQL table using SQLite. Then get our connection string. Oops, going a little bit too quick for myself. .connect. I think it's called grocery. Yeah, grocery DB. Cool, no issues there. And let's just verify it works by doing a quick SQL statement here. Select. Oh wait, forgot to load it into. I forgot to create the table first. Store. You want the table to be called a store transaction. Then our connection. Then index is false. Then replace if exists. Uh, replace. Just delete this for a second. Cool. All right, now let's see, can we read from our table with pandas, read equal. transactions. Cool. So we got our data loaded into a table called store transactions. And let's just get started with window functions. So window functions are often compared to group by functions. And that's because just like group by functions, window functions allow us to perform aggregate calculations such as sum, average, and things of that nature. So let's just begin by doing a review of what an aggregate function is. We're just going to stick with the average function, the average aggregate. So let's just do select average. Then let's just say we want the average transactions for their entire table. Oops. All right, cool. Better select average transactions from our store transactions table. And then let's run that. SQL query connection. Cool. So as you can see, we just calculated the average number of transactions across the entire table and across the entire data set. So let's just say we wanted to see the average number of transactions for an individual store. We'll do something from the following. I'm just going to be copying and pasting this and just making changes to it. So this is the part you guys are probably already familiar with as well, just using the group by. We're going to group by the store number. Let's just see. Right? And let's just add an additional, just for clarity, add the store number in here as well. All right, so now we have the number of transactions for a given store. Okay, this could be very insightful and very helpful if you want to compare the stores against each other, but we still don't have all of the data from the entire data set. What if we wanted all of the data rows in that table, for example? So let me just do a limit right here, just to clean this up a little bit. Oh, can't spell. So that gave us, again, we're associating the average number of stores to the average number of transactions to a given store. Let's see what this would look like if we did this with a window function. So basically the same thing. We're going to remove the group by. All right. Then it's the part that's going to be new to you guys. We're just going to do over. Then we're going to do a limit of 4. And give this an alias. We're going to call this average transactions. All right, so what we basically did, right, is the same value from the entire, so when we just did the aggregate by itself, we just calculated the average, we're getting the same value back for the average number of transactions, but we didn't reduce the number of rows associated with that value. So this would be great if you wanted to compare how a store on a given date and their transactions compared to that average transaction, which can give you a lot of insight. A customer might want that information to use. So that's very helpful. We can also do something such as Like, what if we wanted to see how far a transaction on a how stores transactions on a given date different deviates from that average number of transactions. So we could do sorry. Right. And this tells us, on this day, that for store number 25, the transaction for that day was 770, which is, far short of the average number of transactions. And as you can see, the only thing that, we did was add this over clause to make sure we keep the same amount of rows and we didn't reduce anything by doing this. Already did that part. So basically, the syntax for a window function is as follows. This is the original function we had. Basically, the syntax is start off with your select statements, selecting the columns that you want to use, and then your aggregate function, whatever that is, right here. And then you can add the over clause, which with no over clause in close parentheses inside it as well. And that's just the basic syntax for a window function. So inside the parentheses, you can specify a window, and the inside here is where the actual window function component goes. So this entire thing is called the window component, but the window is defined here. So if you leave this empty right here, if you leave the parentheses empty, let's leave it blank, that means it'll calculate this average number of transactions across the entire data set. So now we're about to calculate the average number of transactions for a given store. So basically, we're just going to do the same thing we were doing before. Select the date, store number, transactions, our overflow, our transaction, our average transactions, our overflows. But inside our overflows, we're going to add partition by the store number. And then let's give this an alias as well. Average by store from store transactions. That's where store number equals 1. Oops, got an error. So,
Oh, you have an extra semicolon there, Micah. So after the word store transactions.
Oh, thank you, Jeff.
All right, label exception.
Select data store transactions.
Yeah, and then you have a fourth quotation mark. Yeah, cool.
Cool. Thank you for that. As you can see, just add a limit here so we don't get the entire. Or store number equals 1.
You just remove the equal sign.
Okay, so thank you for that again, Jeff. So again, we can see that we calculated the average by store, the average number of transactions by store, just for store number 1, and we can compare those to, for each given record, we can compare that to the average. So for example, this transaction for store 1 on the second, on this date was 2,000. 111, but the average for the entire store is this value. And just to verify that this works, we're just gonna change the store number to 4. We can see that the average by the store is different. And all we did was add the partition by, which works similar to the group by. And again, here's the syntax for that as well. And I think that's it. Back to you, John.
Yeah, can you just go back to that last one? Can you just remove the where clause? Yeah, just remove that and remove the limit. Let's see what happens. All right, so you guys see what's going on? It's like, so we have this partition by store number, and just like what Mike was showing us. So you can see like when the store number is 1, we're getting 1523 as the average, right? But then when the store number is 54, right, that's giving us a different average. So this is really, it's like just like group by. The difference, right, which was highlighted is with group by, remember like how many rows we're going to get? 1 per store. If we group by store number, we're getting 1 row per store. Here, notice we're getting the same number of rows, right? In other words, a different, not 1 row per store, but a row per store per day. Okay? And why is something like that useful? Well, what we get to do now, like, it's like, how is this last query useful? Well, we see the average by the store, and then we see the transactions for this day. So we can kind of say, like, is this a good day or a bad day for this store? You know what I mean? Relative to where this store is located. How is this day for this store? And I want to know maybe the same thing for each of the stores. So for store number 54, then we can also look, okay, for August 11th, how well did it do, for this day? All right. So like in retail, right, there's like this same day sales type of thing that they'll look at, right, for a store for a given day. How good are they doing compared to the same day last year? Something like that. So that you just can't do with group by. But with something like this, it's similar, right, where we just define the window, right, then we can accomplish it. All right. And then, wait, questions about this? No? Awesome. That's great. Cool. Thank you, Micah. This is great. We should all give a silent clap or something. There you go. Thank you.
Thank you, Ryan.
All right, cool. So let me show you guys what we'll work on with Canvas.